This ironing thing, I think, is a very useful technique in general to have in mind for optimization problems. It makes them a lot easier. Okay. Now, monopolies raise prices above costs, and this has two effects. One is it transfers wealth from consumers to the monopoly. And while this creates distributive problems, it doesn't create any net social loss. But the second thing it does is it reduces the quantity of goods consumed. Some individuals would be willing to buy the good at cost, but they don't buy it because the price is above cost. And that's a loss. It would be efficient for them to buy it, but they're not buying it. This is the deadweight loss from monopoly. And the reason is that monopoly is forced to raise prices on everyone in order to charge the higher prices she wants to on the inframarginal consumers. If they could tell who is who, if they could tell who was willing to pay a lot and who was willing to pay a little, they could charge each person a different price, and that would eliminate this problem. And the thing is that while you can look at it as a monopoly creates an externality on the consumers, you can also look at it that the consumers, once the monopolist is earning a markup, create an externality, positive externality, whenever they buy products from the firm, right? So a natural thing to do is to try to internalize that externality. So one way you could do that is you could give a subsidy on firms that have market power. That would raise their quantity back up to the efficient level. And we'll talk about some of the problems with that in lecture 12. Another thing you could do is you could just mandate they have a higher quantity, like with cap and trade. And we'll talk about that on Tuesday. Or anything that makes consumers value the product more is going to be socially beneficial. So, for example, you often hear people decrying deceptive advertising. And deceptive advertising is mostly done by firms that have market power, right? Because they're the only ones who profit from it. But deceptive advertising is socially beneficial because it makes consumers value the product more than they otherwise would do, right? And that's basically like giving a subsidy on the purchase of the good, which is efficient if the good is undersupplied because of the monopoly distortion. Okay. So to measure these losses, we consider a Harburger triangle just like we did for any other deadweight loss, right? The only difference is that the size of this triangle is determined by the monopoly's optimization, and we'll talk a little bit about that in a minute, because it'll have a particular relationship to the monopoly profits. Okay. So as usual, there are two different expressions for the deadweight loss. One is the integral between the monopoly quantity and the socially optimal quantity of the markup, the difference between price and marginal cost. So if that's demand, that's marginal revenue, and this is cost, this area is the deadweight loss, the difference between the marginal cost and the demand, between the two quantities. Another expression is that if we integrate on the price dimension from here to here, from the marginal cost up to the price, we can integrate the difference, between the marginal cost price of the minimum of the supply curve
It's like the left
I believe that.
envelope.
I believe that. What?
It's like the left envelope of those two curves. That's what
Yeah.
you're writing, right?
Yeah, but I'm not sure I see now why that's correct. Is that correct, do you think?
Yeah, I think so.
So the min of supply and demand. So that would be adding up these slices, but then how do I subtract off this thing?
Right. Oh, yeah.
It should be minus the monopoly quantity, I think.
Yeah.
Anyway. Okay. So similarly, profits can either be the area of price above the marginal cost curve, so this area here, or they can be the area between the marginal revenue and the marginal cost curve. Why are those areas the same? Well, there's basically like a triangle here between the marginal revenue and the marginal cost. Yeah, so there's going to be a triangle here that has to be equal to the triangle here if I actually drawn things correctly. But I didn't quite draw them correctly. Anyway, sorry about that. And the consumer surplus can also be measured as either the area up here, this triangle up here, or the area between the marginal revenue and demand curve, which is the marginal surplus that the consumer is getting, right? Because the demand curve is the total marginal social benefit of adding one more unit. Marginal revenue is what the monopolist gets, so the area between the marginal revenue and the demand curve must be on the margin what the consumer is getting. So their areas can also be measured as this area between the demand and the marginal revenue curves as you go to the optimal price.
I think to fix that the second deadweight loss expression,
Yeah.
just stick a minus QM.
Yeah, that's right. That's correct. That's what we concluded from our discussion. Okay. So this makes the existence of this deadweight loss makes monopoly incidence fundamentally different than the perfectly competitive incidence that we studied when we talked about perfect competition. So it's still the case that physical and economic incidence is independent of physical incidence is independent of economic incidence. Here that means that if you give a subsidy to consumers, the effect that has on prices is 1 minus the effect that giving a putting a tax on the producers would have. So I'm going to label again pass-through as being the effect on the final price to the consumer of putting a tax on the producer. Now, before we said that the burden of a tax, if you raise $1 of revenue, that $1 comes some amount from the producers and some amount from the consumers. That's not true anymore because there's already distortion taking place. And so there's going to be excess burden even if you're a first unit of the tax, right? It's going to be borne more than fully by the consumers and the producers, right? And in particular, let's figure out how much of it is borne by the producers. So the firm chooses the quantity so as to maximize the profits. Daiichi's not here. Does anyone else want to say what that says about the effect of an increase in the tax on the firm's profits? How much does the firm's profits fall by when the tax increases by a small amount? Quantity, right? Because by the envelope theorem, as the firm is maximizing with respect to quantity, we can just hold quantity fixed. If we hold quantity fixed, then this is fixed and this is fixed, so it just increases by the quantity, right? That's right. Okay, so that means that the firm bears the full burden of the tax. Before the tax burden was split between the two sides, here the firm is bearing the full burden. But consumers are still bearing the pass-through rate times the quantity. And so the excess burden is proportional to the pass-through rate of the firm, right? And so that says that the ratio of reduction in consumer surplus to reduction in producer surplus from the tax is the pass-through rate.
Glen.
Yeah.
So when you say excess burden, you mean like the government is producing more deadweight loss proportionally per tax than they would if it was a competitive market?
Exactly. In a competitive market, some would be borne from one side, some would be borne by the other side. Here, for every unit of tax they raise, they create a burden proportional to the pass-through rate that's in excess of the revenue that they're raising, or is equal to the pass-through rate. Now, just as before, remember that we could integrate up these local things to find the global value in the market. And so the ratio of consumer to producer surplus by the exact same argument as before is exactly the average quantity rated average value of the pass-through rate. Okay. So let me give you a simple graphical representation of this. So the increase in marginal cost comes from shifting. Okay, if we increase the tax, right, that shifts the marginal cost curve up like this, right? How much does that reduce the monopoly's profits? Well, the monopoly's profits are the area between marginal revenue and marginal cost, right? And the amount that area is reduced is exactly the strip along this area between the green and the yellow before it hits the marginal revenue curve. Now notice that this little triangle here is very small compared to that full strip. And to the first order, by the envelope theorem, that's basically 0. And so it's the area of this strip that is the value, which is just the quantity multiplied by the change in cost. Okay. Now, notice that increasing the tax reduces the consumer surplus, and it also reduces producer surplus, right? And it raises deadweight loss. Now, I want to find something that brings down deadweight loss and brings down producer surplus. Why do I want to do that? Well, remember the way that we integrated this stuff was that by raising the tax high enough, we got to the place where there's no consumer surplus and no producer surplus, so we could get a ratio of consumer to producer surplus. So now I want to invent something that will decrease deadweight loss and decrease producer surplus. Let me focus on the case of constant marginal cost. Now let's imagine a new firm coming in to compete with this firm by exogenously producing some quantity of a good, QS, right? And let's call Q the total amount that's produced in the market, right? This competition is going to increase the total amount that's produced in the market. Eventually, the firm's profits will be eliminated because prices will be driven down to marginal cost by this competition. And that will also eliminate all the deadweight loss, right? And so this is an intervention that can eliminate both deadweight loss and producer surplus, and so we can use it as a way to sort of integrate up to measure the ratio of deadweight loss to producer surplus. Okay, so the firm's profits, if the total industry is producing Q, and the competitor is producing Q tilde, are going to be the price times Q minus Q tilde minus the cost. So the first order condition is going to be that if we take the derivative of this, P plus P prime times Q minus Q tilde, because I have fewer units that I'm reducing the price on, is going to be equal to marginal cost. And so what does that tell us about the effect of raising Q tilde on the amount of production in the industry? Well, notice that increasing Q tilde is the same as giving a subsidy of size P prime, right? Because if we just move this to the other side, increasing Q tilde is exactly the same as changing the marginal cost by an amount P prime, right? And so the effect of a change in Q tilde on P has to be the same as the pass-through rate times P prime, which is the same as affecting Q by an amount that's this divided by P.